Good morning, everybody. I'm a little behind because I was packed with meetings, but here is finally the homework helper for 510. Let's go ahead and look at what's going on here. The first one is a system of inequalities, and let's just read the directions. For each of the systems of inequalities, so systems, of course, meaning two or more equations, or in this case, inequalities, determine if the given coordinates are solutions to the system. And then it wants us to show our work. All right, that's not too bad. So all we really have to do is start looking at this first one here and see if each of those points is a solution. Now, it's not like you pick A, B, or C, there's only one answer. It says we gotta look for if the given coordinates are solutions. So we have to try each coordinate. So I'll go ahead and start this with A here. So this is 6, 10. And remember, this goes x comma y. So is 10 less than or equal to 3 times 6 minus 5? Well, is 10 less than or equal to 18 minus 5? Is 10 less than or equal to 13? Yes, it is. Okay, so it satisfies the first equation. Let's see if it satisfies the second equation, because again, we're looking to see if it satisfies the system. Okay, so let's do the next one. The next one is y is greater than or equal to x plus 2. So y is 10. Is 10 greater than or equal to 6 plus 2? Is 10 greater than or equal to, 6 plus 2. My brain was already thinking that's going to be 8. And of course, 10 is not greater than or equal to 8. A does not satisfy our requirements. All right. So we're going to try this again. We're going to try it with 1, 4 here. So is 4 less than or equal to 3 times 1 minus 5? Is 4 less than or equal to 3 minus 5? Is 4 less than or equal to a negative 2? It is not. So I can rule that one out. Don't even have to do the second equation. If it doesn't fit 1, it doesn't fit the system. And finally, 8, 15. Is 15 less than or equal to 3 times 8 minus 5? Is 15 less than or equal to, what is that, 1624 minus 5? Well, yeah, 15 is less than or equal to 19. So it works for that one. Let's try the second equation. Is 15 greater than or equal to 8 plus 2? Is 15 greater than or equal to 10? Yes, it is. So C will be our answer because it satisfies both of the equations. It does the whole system. All right. You'll do that for 2 and 3. Next, let's look at the set. All right. Write each equation in slope-intercept form, and then based on slope-intercept form of the equation, determine whether the system of equations has 0, 1, or infinitely many solutions. How do you know? Okay, so this is important, kind of based on what we were talking about yesterday, when we were talking about the way we know whether or not there are special cases. So remember, we have kind of 3 different ways a pair of lines can go. Okay, the first way, which is the common case, is if we had a Cartesian coordinate plane, we have one line go like this, one line go like this, we see that they intersect and there is one solution. So when does this happen? When they have different slopes. Okay. Next, the other way that we know this is, or the other options that we have, is we can have situations where we have one line and another line that runs absolutely parallel, okay? They're running parallel to each other so they never touch. This is the same slope, but different y-intercept, right? Because it crosses here versus here. So when we look at an equation, if it has the same m, same slope, but a different b, different y-intercept, we could tell that there's parallel and there's 0 solutions for this. And then finally, the third option, the third thing that could happen, is we can have a situation where we have 2 lines that happen to be the same line. So it's like one line right on top of each other. So this is the same equation for 2 lines, and that means there is an infinite number of solutions. So this would have to be the same slope and the same y-intercept. So let's go ahead and do this problem here and see what's up. So it wants us to put these equations in a slope-intercept form. And what I see here is that the first one is in standard form and the second one is in slope-intercept form. So I only really need to manipulate the first equation. So that's what I'm going to do. So I have 3x minus 4y is equal to 13. So I want this to end up looking like y equals mx plus b. So I'll subtract my x term, giving me negative 4y equals negative 3x plus 13. I will divide by negative 4. I will divide by negative 4, giving me y equals 3/4 x plus, or I'm sorry, minus 13/4. Okay, and then I compare this to this equation here. This has a positive, or this has a negative 3 slope. This has a 3/4 slope. I have different slopes, so that's enough for me to say that there is one solution because they have different slopes. I'll go ahead and do another one of these just to just so that we kind of see, because I want you guys to be more familiar with the special cases as we move forward. So let's look at this one. See, these are both in standard form, so I need to get them into y equals mx plus b form. So I'll go ahead and start with the first one. I have 3x minus 3y equals 3. I'll subtract 3x. I have negative 3y equals a negative 3x plus 3. Okay, I'm going to divide by negative 3, divide by negative 3. This gives me y equals negative 3 divided by negative 3 is 1, so x minus 1. Okay, I'm going to do the same thing here. So I have x minus y equals 1, so I'll subtract x, negative y equals negative x plus 1, divide by negative 1, divide by negative 1. So I end up with y equals, that becomes a positive x and a negative 1. So you can see here that what I end up with is I end up with the same equation. I have the same m and the same b. So how many solutions? I have an infinite number of solutions. How do I know? Same slope, same y-intercept. Okay? So that's enough for me to know that it's going to be exactly the same. If they had had different y-intercepts, if this had been like a 2, then I would know that there was 0 solutions, because they would have the same slope, but different y-intercepts, much like this example that we talked about earlier. Okay. All right, let's move on. Solve each system, write your solution as an ordered pair, or indicate if it has no solutions or infinitely many solutions. So we're pretty much doing the same thing. But this time it wants us to solve it if there is an ordered pair. So, you know, back here on number 4, we didn't actually solve it. We were just able to say that there was one. Now we're going to be expected to find it if there is. So I look at number 8 here and I wonder, can I eliminate? Yes, my x's are lined up to eliminate, so I'll just subtract this second equation from the first. X minus x is 0, 4 minus 1 is 3, and then 6 minus 3 is 3, so y equals 1. I can then plug y back into any equation. I'm going to choose the second one because it looks simpler, because it's just x plus 1 equals 3. So if I subtract 1, x equals 2. So the 0.21 is my answer. Okay. Let's try a more complicated one. I'll go to number 9 here. So what I see here is I see that they are not both in standard form or slope-intercept form. They are in different forms. And so this creates a little bit of a problem of how I should solve it. Go ahead and zoom in. But what I can do, and what's actually pretty cool to do, is I can use another method that we learned called substitution. Because if y is this, then I can take this and plug it in for y. So I get 2x plus, and then I substitute in for y what y equals. X minus 4 equals 5. So now I can solve for my x's. So 2x plus x is 3x equals 5. I can add 4. I can add 4. 3x equals 9, so x equals 3. And then I can just plug that in. Again, I like the second equation this time. Y equals 3 minus 4. Y equals negative 1. So the point 3, negative 1 is my solution. Pretty cool. And I can do the same thing with number 10 here. Number 10 lends itself to substitution as well because we have y isolated on this side. So I can do that here. So this becomes 2x minus 2x plus 1 plus 1 equals 0. So now I can solve. So this negative sign out here kind of distributes in, so it becomes 2x minus 2x minus 1 plus 1 equals 0. We'll look at what happens here. 2x minus 2x, that cancels. Negative 1 plus 1, that cancels. So I get 0 equals 0, which is true. 0 is 0 equals 0 equaling 0, of course, is true. But what we don't do is we don't get an x value and we don't get a y value. And so here's what I want you guys to see. Is if this is true, if by the time we do all this funkiness, we get down here and we get a 0 equals 0 or a 1 equals 1 or something that is a true statement, what that means is it doesn't matter what our x or y was. I could plug any number into x here. If this were 1,000,000 times 2, so 2 million minus 2 million, well, they would still zero out. So any number of x I could plug in and it would work. So what this actually tells me when it's true is that there's an infinite number of solutions. Okay? There is an infinite number here because no matter what value I choose for x, it's going to cause this to be 0, 0, which is a true statement. So any x value will work, which is kind of cool. I kind of like that. So that's one of those cases. So remember now, if it's an infinite number, that means that these two are actually the same line. And if we wanted to, we could manipulate it and prove that it was the same line. All right. So that will that do that for today? I think that'll do it for today. That's a lot of work. There's some more problems for us to check out. Be mindful of some of these differences that we've seen so far. Be mindful of the special cases. And we'll do the test review next. Have a good one.